Good afternoon, everyone. Here's Rachel from King's College London. Today, I would like to present a project worked with Professor Nishan Sensory according to our Tangled browsing histories. So over years, the browser history has become more and more complicated. To provide a visual view of the browsing data, we create a browser extension to visualize all the interconnections across different first-party websites. Until today, our Chrome extension has been installed by over 2,000 users across the world. Here, I would like to show you some examples of my real browsing data. After the first time you visit and install our extension on Chrome Web Store, it will provide you a very clean browsing history because we will not require any previous cookies from your site. Then you might visit some news website like theguardian.com. So the first-party website will be served at the round circle in the middle, and then all the third-party trackers are served at the triangles around it. Then we back to Twitter.com, and we could notice there are two interconnections are built between these two first-party websites you visit, Twitter.com and theguardian.com. If you also do some shopping behavior on Argos, more and more interconnections will be built across three different first parties. So the more first party you visited, the more interconnections will be built on your background. Apart from that, imagine I'm a user from another country like China. We might choose Baidu instead of Google. And surprisingly, the Baidu.com will serve as a very independent ecosystem apart from those UK popular websites. So we keep accessing some popular websites in the China, like some news website and shopping website. So after a few seconds we spent on this website, we back to our extension and notice the popular website located in different countries will develop to separated third-party cookie ecosystem. And based on our extension, we could notice that websites loaded from different countries generate two separated third-party ecosystem graphs. And compared with the UK graph, only 3 interconnections are found in the China one, which is much fewer than that in the UK. So we will back to the separation later on this talk, but also think about the questions. So first, which set of websites is more interconnected? And second question is, where do users lose privacy more quickly, China or UK? Then we back to this project title. So this project is mainly about understanding how these powerful third parties worked for users. And our main contribution is to develop a new metric which could be used to measure this interconnectedness of the third-party cookie ecosystem. Firstly, we will show you a simple example about how these third-party cookies work and target our users. So when we go and do some shopping on like Argos website, some third-party trackers located on this website will load their tracking scripts and record our user data. Then we are browsing some friend message on Twitter, and surprisingly, we will find some advertisements related to the things we tried to shop for a few hours ago. So how could this happen? The way it happens is that these third parties that dropping cookies from the shopping website are used to identify our identity on the other first-party websites you are browsing. So in such a case, they could offer the targeted advertisement to each user. That's the way they generating the third-party cookie ecosystem. Also, we could see these third parties are connecting different first-party websites which are supposed to be independent. Therefore, to quantify how third parties and first parties interconnect with each other, we developed a metric called tangle factor. But how could we calculate the tangle factors? To calculate the tangle factor, we need to draw the first-party interconnection graph. So let's back to our extension data. Here we use round circles to represent our first-party websites, like Argos or Google, The Guardian, and other triangles are third-party trackers around them. Here we place some third parties in red because they are connecting more than one first party. For example, this third-party tracker is connecting Google and Argos when we are browsing websites. So we pick up all the first-party nodes and third-party trackers, drawing the lines between them based on whether they are connected to complete this bipartite graph. And then we do the projection of all the first-party nodes on this bipartite graph and create the edges based on whether they are linked to the same subparty. Like they have the edge between the Argos and Google because they are linked to the same subparty tracker. So we call this graph as a first-party interconnection graph. But how could we make it more private? We should avoid sharing anything between the Argos and Twitter, because there are at least one third party connecting them. So these third parties know both activities from two first parties. Imagine if we visiting the Argos and then we access Twitter in another browser. There would be no way for third parties to share data by matching their cookies. So if there is an edge in the first-party interconnection graph, we need to place them into different containers. That's the way we coloring this graph. And based on the coloring, we should place the same colored websites into the same container. In such case, there's no interconnections will be built in each container, and no connections across different containers will be allowed. So the minimum number of colors needed to color this first-party interconnection graph is its vertex dramatic number, and in this paper we call it Tangled factor. Firefox gives us a function to separate these containers, keeping your personal activity apart from other working activities, banking, as well as shopping activities. The extension called multi-account containers could help the user to keep different identities between the different websites. But this kind of assignment has to be done by users manually. That is to say, the user might put the Argos and Twitter or Argos and the Guardian into the same container because they have no idea about how these subparties will be shared between different first parties. So this paper would provide them the method to separating these websites based on the interconnections. In this paper, we would like to discuss three questions here. Firstly, we quantified tangled factors across different users. We questioned the number of containers required for separating first-party websites. Here, we use a metric to measure the violation of different users' privacy. Secondly, we ask whether the different countries have different tangle factors to measure the level of privacy across different countries. And lastly, we compare different privacy products to measure which one is the most effective way in decreasing the interconnectivity and improving our user privacy. And let's start from the first question to quantify the tangle factor across different users. First, we did a measurement based on the Alexa Global Top 2000 dataset. And let's bring an example. Assume there is a person who located in the UK, and he visits top 100 website. What is his tangle factor? Obviously, the minimum number of required containers to separate his browsing activities. If there is no first-party website should be know each other. The number of containers they need is nearly 60 different containers. And then visiting the same site of top 100 websites from China. The surprising thing is that in China, you only need less than 15 containers. So that means you may need nearly 4 times as many as containers in the UK.